Okay, this should be a pretty quick video. We've been working on those probability word problems, which can be difficult and you may need to do, 3 or 4 times until you get the hang of it and find the patterns. This topic of probability I call reading off of charts, and it is much simpler. We're going to do one example here, and then there are 3 examples from handout 8 that you can do after this. I think on the notes, so remember there's a notes file. Should be number 2, 3, and 6 on handout 8. And again, I'm going to write up this data table in a minute, but these notes are in the file before this video. So, going back to those probability rules we put on lecture the other day, remember we had the multiplication rule, and it said if the 2 things are independent, then we knew that the probability of A and B, that intersection, equals the probability of A times the probability of B. We're actually going to, and that's what we used in all the word problems, right? That's why we were multiplying everything. We're going to use this formula in a backwards way. We're going to get this number off of the data table and get those 2 numbers off of the data table. We're going to multiply it, and then we're going to see if the number's equal. And if it's equal, we're going to call it independent. And if it's not equal, we're going to call it dependent. So you're just looking to see literally if it's equal. If something's just close but not exactly equal, we're going to call it dependent. Okay, so, and another rule you're going to see is the addition rule. A or B, remember that, maybe I should highlight that. Remember that word or equals the probability of A plus the probability of B minus the probability of A and B if there's an intersection. So far, this was just reviewing what we've already done in class, but we're going to be applying it. So let me erase this. So, see, that's still not going to be clear through the video. This data table is in the notes that go with this video, but I'm going to write it up really quick. So, let's see. I couldn't write this before I started the video, so y'all gotta wait about 30 seconds. I'll tell you what this data is in just a second. Okay, so this was real data that I stole from somewhere. It was broken down by male or female, and it was the highest education that you obtained. Bachelor's, master's, some type of professional degree like an MBA or something, or your doctorate. So don't get confused. Like most, even of my colleagues, if they earned their doctorate, of course they would have earned their bachelor's, but this is the highest degree obtained. So there was not double counting in there. So the first question we're going to do, we'll start easy. What is the probability a person is female? Okay, well, females, I had 1481 divided by the grand total. So what these are is, right, these are the row totals and the column totals and then the grand total. Let me maybe highlight, that's the grand total of how many humans we actually asked the survey of. So I had 1,481 females over a total of 2,506 humans. Stick that into your calculator. You'll get 0.591, or you can show it as 59.1%. Doesn't matter. All right, let's up it a little bit. What's the probability a person has a master's or a doctorate? Okay, so here are my masters. So I don't care about their gender, right? I just want them to have a master's. I have 671 that have their masters, and then doctorate, I guess I have 59. And again, there is no double counting on there. So this is sort of the easier addition rule. I think we did it with dice probably about a week ago. You can't have your master's and your doctorate at the same time, and that was what I explained about this data. It was just the highest degree. So we're just going to divide by how many humans we had total. And if you stick that into your calculator, 0.2913. So again, this would have been like the probability of A plus the probability of B. There is nothing to subtract because those two numbers, these two numbers, they're in two different columns. They are not double counting. You're going to see what I mean by double counting on number 3. So if you still need to write, pause me because I'm going to erase. Okay, so number 3 is really important. What's the probability a person has masters or is female? Okay, so this is kind of like, you know, event A is having your masters, event B is being female. Okay, so let's see, I have 671 masters. And I have, oops, sorry y'all, 1,481 females, but, so this is the probability of A plus the probability of B. And remember the addition rule says we're supposed to subtract off the intersection. I do have an intersection here. It is all my females with their masters. So let's see, females and masters. I have double counted the 411 because see how the 411 was part of the 671, but the 411 was also part of the 1481. I do want to count that 411, but I have double counted it. This is when I was doing that Venn diagram with the snowman. So I need to subtract the 411. And then divided by the 2,506. If you stick all that into your calculator, you'll get 0.6947 or 69.47%. Again, I never care what what form it's in. All right. Now I'm going to go on to the really big part of this, checking for independence. So I'm about to erase, so pause me if you're not ready. We'll call this number 4. So I do have to tell you which two values of the variables I'm interested in. Is being female and having your doctorate independent. So we're checking that. Okay, so what we're going to check, this is that multiplication rule that I started the video with. I need to check is the probability of female and doctor. So see, I'm putting a question mark over my equal sign because I'm trying to figure out, is this a true statement? Does that equal the probability of female times the probability of doctor? I'm trying to figure this out. I don't know that this is an equality statement, right? Okay, female. We had 1,481 over 2,506 times doctor. We have 59 over 2506. And when you have the data table, I mean, we did this a second ago, the intersection, the and, you're not doing any fancy stuff. You're just looking at your data table. Sorry, that was from the last problem. Let me get rid of that. Okay, you got to be female and have your doctorate. So, and I hate that my photo booth keeps kind of going in and out. See how I circled the 32? There are 32 of those that have both qualities. So I beg you, everyone needs to practice putting that into their calculator to make sure you get the same answer I get. Don't trust that you know how to use your calculator. This side's going to give you 0.0127. And again, we're trying to ask ourselves, is that equal to what that side is? If you do that math, you'll get 0.0139. And of course, we're back to those 4 decimal places for numbers less than 1 that I've always wanted. That is not equal. I know it's close, but remember we said we're going to be an all or nothing case. It's either equal or not. So that's actually not equal. So thus, it is dependent. Dependent. Independent only happens if it turns out to be exactly equal. So there are, particularly, this is the big stuff right here. There are 3 problems on handout 8. I'm pretty sure all 3 of them ask you to do this. I think 2 of them turn out to be dependent and 1 of them turns out to be independent. So you'll get to practice and see how each one of those looks. All right, that is all.